One of the limitations within GAT is to perform automated ganglia segmentation, you need two channels. One for hue, the pan-neuronal marker, and one that labels the ganglia. So this could be any marker that can label all the fibers in the ganglia. And in this case, it's the sample image we're using is GFAP, which is the glial fibers. Now, this is not always practical to have two channels, and uh, we can sort of get an idea of the ganglia based on how the neurons are arranged together, and that's essentially how we identify a ganglia, is by looking at how they're clustered together. So here we have two ganglia, for example, and we can use the hue labeling on its own to define this, and this is a new feature we've added. So this video, I'll just demonstrate the principle of this. So I'm using CLIJ within Fiji to demonstrate this interactively. So this here on the left is actually in this neurons which are segmented from this image. So we ran it through GAT and line neurons here only, and we got this output. Now, in order to define a ganglia, and how we go about it is in this particular script or this particular workflow, the way we do it is we expand each cell by a specified radius, or specified distance. And if they touch each other, they form part of the ganglia, because if they're generally clustered together, it means they're quite close to each other. So to illustrate that, let's say I expanded by say 14 pixels. So you can see that they all became bigger by say around 40, expanded by around 14 pixels. And then I say, okay, if they're all touching each other, they form part of one ganglion. So you can see here that in green there's one ganglion here, and in white there's another ganglion. So this is one sort of simple approach to identify ganglia. Now the issue which you can probably foresee is that it is very dependent on this distance you define. So here I'm defining it by pixels, but just to illustrate the point, say if you define a low distance, or like a much smaller distance, so that means I will get distinct ganglia here. So here I probably have like 10 ganglia here, and this will only capture the cells that are really close together. Say if I go really large, it'll capture cells which are really far apart, and then you can see it's formed one massive ganglia here. So this is the bit that will need optimization, is sort of figuring out what value works for you. So in this, I'm using 13 as an example, but so we've added an extra script or macro where you can test these values. And you can do this in microns, so you don't need to know the pixel size, sort of the pixels. So it doesn't matter what the image, how big the image is. You can enter a value in microns to then to figure out the ganglia. So this script is provided in the GitHub repository. So if you go to in the repository, if you go to GAT sample images and ganglia segmentation, there's a script and there's a label image. So just to illustrate how you'd run it, I'll just close everything. Yeah, and I'll close the script, and I'll just drag. I've downloaded. Just drag it here, and also open the image. So when I say a label image, then all the neurons should be individually segmented, and they'll essentially have a unique color. So this is what you call a label image. You can see that each cell has a unique color. Now once I have this, I go to run. I click run here, or I can click run here. I click run. It's I forgot. Obviously, you can actually select the image while you run it. So I click run. I browse. I select the image. Press OK, and it'll provide all those windows which you saw earlier. And this is just so you can play around with this and sort of understand how this goes, and maybe even try a different image. So I'll just, what you do need to, you just need to minimize the dialog which says greater or equal. Just minimize it, don't close it. And now we have the label image, the dilate labels one, where you can play around with the dilate values, and this ganglia. Now this is just for illustration purposes. the actual way to do it is I'll show you how to go about that in the next video.